Aber Well, good morning, everybody, and welcome back to those who attended yesterday, and welcome to those who are joining us for the first time today. For this, the second of the 2 mornings of the No Dig Live Sewer Rehab 2020 Plus webinars. Now, my name's Ian Naismith. I'm the moderator for today. And as you're aware, the biannual No Dig Live exhibition and conference that would have been staged this week in Peterborough, when suppliers and water companies would have had the opportunity to meet, has had to be put back into next year. So instead, the UKSTT, Westrade, who organise the No Dig Live, and the Sewer Rehab Contact Group of UK and Irish water and sewerage companies that I chair, have come together to collaborate to provide this series of presentations from the water companies. I mean, as we heard yesterday from Rob Kelly, if we had been driving to the Peterborough Arena today, we would have literally been driving over some of their current rehab. Now, just to be clear, because I appreciate the message perhaps has not got through despite various emails and notes, that we had a slight change to today's lineup, as unfortunately at the last minute 2 presenters were not available and could not be replaced. So we had to cut the Scottish Water presentation, which would have just been finished a few minutes ago, and James Devereux from UU is not available. So for his session, which is after Thames Water, I brought forward my summing up, and I've expanded that into a presentation talking about an overview of the issues that have been raised or are being raised over the 2 days. Now, each company's session is half an hour, 20 minutes roughly for a presentation, and the remaining time for questions. You can pose a question if you use the question box that is on your screen. You won't be able to see the questions, but I, as moderator, will be posing the questions to the speakers. We will have one break, which will be at 11:15 to 11:30. The event is being recorded, and the PDFs of the slides will be made available after the event by Westrade. So that concludes my introduction to today. And so I have pleasure in passing over to Mark Lusher of Thames Water, who is going to talk us through their current rehabilitation work. So Mark, over to you. Hi, Mark.
Excellent. How are we doing?
I can hear you. Yep, and we just need to see your slides up.
Perfect. Let me just get those up for you.
So we'll just take a moment,
Right.
everybody. And yep, and you want to just change the view to the full screen, I think.
Yeah, no problem. There we go.
And takes a moment. Wait a second. Yep. I think we've got the full screen and your next slide at the moment, but nearly there. Okay.
Is that there now?
Takes a second. Well, perhaps you'd just like to carry on. We can.
Yeah, let me just try one more time and just get it onto the. No problem at all. Here we go. Try that one. How does that work?
Yep, looking good. Over
Looking
to you.
Good. Perfect. Lovely. Thank you very much. Welcome everybody, and thanks for that introduction there, Ian. A number of you will obviously know me from various things in the industry for many, many years, and probably haven't heard much from me for the last 5 years or so. And the reason for that is that I've been working within Thames Water, looking after a lot of the complicated and fiddly and interesting jobs. Currently a really strange title of Capital Infra Solutions Lead, and what that simply means is anything tricky and nasty comes into a team that I'm part of, and we deal with the interesting projects, putting it mildly. So that's where I've been and what I've been up to. What are we going to talk today about? So a few bits and pieces. We'll start with the Thames Water. What do we cover within Thames Water, which is obviously a very large area. How do we currently manage our sewer rehab, and some of the issues that we're going to be talking around. So, where is our principal interest going to be during AMP7? Some of those strategic drivers, and there are some opportunities to innovate. We've got some tricky things that we're trying to deal with, and I'll take you through a few of those as we plow through these slides for now. Thames Water. Obviously, very large water company. We have somewhere in the region of 109k of 109,000 kilometres of sewers, and a big area sort of covering a lot of London, but also the Thames Valley, so all the way down to Cirencester, up to Banbury and places like that. It's interesting, 4.6 billion litres of wastewater per day. You put that into some sort of perspective, 53 cubic metres per second is the average sort of thing, or a swimming pool, an Olympic swimming pool in 47 seconds. That's the way we tend to look at it. But when it rains, wow, you do realise how much hard surfacing there is in London when it rains. So we've very, very interesting place to work. With those sewers, the great part of working within Thames basically is we have a lot of the original Bazalgette sewers, and I cannot comment more that the quality of those sewers built there is phenomenal. They still look the same as they do from the day we actually they were built, and some of the rehab work we have to do on those is sacrilege in my view. When I have to demolish a Bazalgette structure, it's rare that we do it, but really hate to have to do it, I'm afraid. A lot of pumping stations, 5,235 pumping stations, and we have some monsters, obviously. The biggest one is capable, although we don't use it at that rate, of 35 cubic meters per second if we came down to using that, and that would be absolutely going for it, to be honest. But obviously that's some of the sort of terminal pumping stations that we have. How do we currently do things? And this is where a lot of change is coming into the equation at the moment. Too much reactive still going on. With this sort of reactive work, there really is a trick about these things these days, which is to actually deal with things earlier. Don't have to react. If you react at the right time, you're going to actually deal with things a lot cheaper, and I'll talk more about that in a sec, sort of thing. So we're trying to get away from reactive and get more into the risk modelling and actually coming up with proactive sort of solutions to the work. To do that, though, we need to inspect. And I've come from nearly 40 years now, probably, of working in the industry, and with CCTV and that, there isn't enough of it. We need a lot more CCTV surveying. So we do a lot of CCTV now. There's a lot more happening than probably was in AMP6, and certainly more than AMP5 going on. And really using that information from that data coming back in, we are now certainly actually doing programming, sensible programming, and dealing with the issues at an early stage as far as possible, using the most appropriate techniques. Prioritization is a big thing. We don't have never-ending budgets, obviously, and if we can actually get in there at the right time, prioritize, deal with those assets, we're going to find that the problem will be dealt with for much more efficiently, with less disruption to the public, to customers, and at a far cheaper rate. We have a sort of theory of zeros that we tend to use. If you actually treat something when it's a patch, you've got a price. If it goes to a liner, you add a zero. If it goes to a partial collapse, you add another zero. And certainly in central London, where we're working in those areas, if we get to a full collapse, you can add another zero. Something can go from £1,500 to £1.5 million in a very short space of time. And that's really what it's all about, is actually inspecting, realizing, and actually prioritizing to deal with that. There's a number of the problems that I'll show you in a minute. If we'd intervened on those at an earlier stage, with intelligence, shall we say, we certainly could have actually dealt with these issues far, far more effectively. And it's that timely action, ultimately, for the whole life costings and stuff like that. If we do intervene early, it really is going to be very, very important. It's going to be much more efficient, and it gives us the opportunities to come up with solutions, innovative solutions. I work in a very sort of reactive world, and it's a great place because we can use innovation a lot more probably than the more traditional parts of the business, and indeed we do. My whole philosophy is bring innovation in as far as possible, and it's difficult to steer it in sometimes, but that is the game. That's how we're dealing with it. There's a lot of the smaller sewers, obviously, we have to deal with as well. I primarily deal with the larger, more high consequence sort of sewers, but we term a lot of stuff as around critical assets. It could be quite small, but actually, if you look at it, the cost of remediation can be extreme. So I'll use one example. We've got right in the middle of central London, a 9-inch pipe. Where it is, if it was in the country, in the sticks, would cost next to nothing to repair it if it collapses. This tunnel, this sewer is next to Madame Tussauds. It's under the railway that runs along under Marylebone Road. If it does collapse, the cost is astronomical, and it's only a little 9-inch pipe, 8 meters long. And you can see some of the sort of difficulties we do deal with on those sort of circumstances. Right, let's go through some of our sort of current interesting projects and some of the problems that we are dealing with now. So hydrogen sulfide attack is a major one that we're having a lot of trouble with presently. Okay, you can go in there and dose the pumping stations, etc. But what we are finding is that a lot of these places, unfortunately, you know, from previous decisions, I don't know what it is, but it's actually too late. Now, this one here is a classic. This is probably one of the worst I've ever dealt with. We had a sinkhole that developed under a factory building, effectively somewhere that serviced fire extinguishers. You wouldn't believe from that photo on the left there. That happened to be next to an adjacent building. That adjacent building is an old pumping station. It's got a deep shaft on it, and it happened to be next to a railway. So you're putting all sorts of things in place to actually deal with it. If you look at the picture to the right, though, it'll give you an indication where all that shingle is. That shingle was the footprint of a building previously, and in the background you can see a little sort of bit of fencing. That's actually a substation. So you put all these bits and pieces together, and this was one of those beautiful jobs that comes together, you know, once every 10 years or so, and you have to deal with it. The sinkhole was around 8.5 meters deep. The top of it was 8 meters in diameter, and it developed within the building. Basically, when we opened when the actual collapse occurred, we had to find a very quick method of repair, and that repair was to dump hundreds and hundreds of tons of shingle in there. We had to keep the railway stable, so a very, very interesting project to work. Once you've done that, though, you know, you start to have time to think. And what was the problem here? So the GIS mapping, unfortunately, was a little bit incorrect. What we quickly realized was we were dealing with a transfer tunnel. It was actually listed as a 450 mil gravity sewer. That transfer tunnel actually picked up 2 rising mains, 500 diameter rising mains from 2 separate pumping stations. And you know, we sort of quickly realized that what was on that GIS was very, very different to the circumstance we had. What did we find? So big deep excavation next to a railway, not the best of things to do in anybody's book. We had to dig out a very large shaft. Now, we took a decision early on that we didn't know what we were going to find. We actually structured that shaft big enough to actually do some serious work from, so to allow us to do some pipe jacking if it came down to it. The key images here probably are the second one in from the left and the bottom one on the left there as well. That's when we actually got down onto the sewer. One of those rare occasions I get down there, get down and dirty with a shovel these days. But we actually found the sewer had disappeared. This was actually a concrete jacking pipe that we're looking at here, and was installed in real terms not that long ago in the 90s. The pipe had basically gone, and the bottom image you're seeing on the left there is all the rebar hanging in. Key to what we're looking at there is that that pipe that you're looking at in the bottom image there is actually 60 meters away from where the rising main is discharged into a large chamber, and that absolutely frightened the living daylights out of us because of where it is and what it was. We ended up emergency foam concreting up the pipe. And then what you're looking at basically on the right hand images are oversleeving. We had to actually push a new tunnel through, oversleeving it onto the existing tunnel. And that's because of site constraints with the railway and the old pumping stations and things like that were around there. It was incredibly difficult to do any diversion works. I talked earlier about interventions. If this had been picked up a lot earlier, this would have been a fairly straightforward lining job. In reality, okay, it was difficult. There's 700 litres a second of flow coming into this system from 2 pump stations, but it's one of those jobs where it would have been, far, far easier to have dealt with if we'd intervened at the right time. There are, everybody's going to have that. A lot of people on this call will see examples of this sort of type, but certainly the interesting jobs that keep us going and keep us motivated, these ones. A lot of you know me from the railway work, so a lot of my career has been obviously 20 years of it or whatever was in the railways. Now this is another sort of interesting one that came back, an asset that we considered was owned by Network Rail. Told them about this many years ago, and when it came down to it, they decided actually it's yours, and managed to eventually produce the documentation that proved it was owned by us. They did that 4 weeks before they were due to relay the railway tracks above it, mysteriously. And what we actually got here is the condition of that particular sewer. I think it was around a sort of 900 by 600 egg that was running through there. And you'll see that these major failures, some, caused by detriment by age and stuff like that, and some caused by knocking new catch bits into the top of it, obviously. When you find a sewer where the bottom has slipped out like it has in the bottom of that that image there, that is actually under the railway tracks, and the bottom of the sewer has just disappeared. These are high density commuter tracks here, and it's right on the edge of a set of points. So it's in one of those lovely areas where it's absolutely critical that you do something about it quickly. We had to react to that incredibly quickly, and when I say incredibly quickly, that was literally 4 weeks. We had that stabilized and in a situation where Network Rail could come in and actually undertake their heavy works to actually look at the to get the railway track up to a decent standard again. One of the other things we get is a lot of third-party issues. Very, very dense urban areas, obviously, we've got, and there is a lot of very expensive construction works going on. When I say interesting, there's a very common theme to this, and it's certainly is piling. So piling near to some of the larger sewers, but also some of the sort of more minor ones. We're forever spending time cutting concrete out. So we're using a lot of robotic techniques now, high pressure water and ultra high pressure water cutters and all those sort of bits and pieces to get this out. But it is a massive problem. And solutions to that are going to be something that we really, really are keen on. The one on the left there is interesting. This is this was an exceptional one to see. Dead center hit with a 600 diameter pile on a 1.8 diameter sewer. If I was to tell you that's actually 8 meters deep and within about 2 meters of a railway track, it's pretty frightening that they're there. Luckily, it was a dead center hit, and actually the thing was judged to be fairly stable. We're trying to find a way of repairing this at the moment. That pile is actually taking load, so we're having to find a method of getting that pile out. With the structure that's above it, luckily it's not a building, it's actually a structure that's above it, to actually sort that one out. Concrete's great. We spend a fortune removing concrete from it. If we can find out who put it in there to start with, great, we'll get the money back off of them. But there is a lot of money being spent removing concrete from sewers, and techniques and stuff like that to do it. Invariably, it's also in an area where they've done some piling work or whatever else, and they've managed to smash the side of the sewer at the same time. So not only are you having to remove something very hard from that sewer, at the same time you're trying desperately to stabilize that sewer. And we've ended up doing what's essentially a heading within a sewer on a number of occasions, just to keep things stable, so we can actually get some sort of structural concrete out of these things. So it makes life very, very interesting, putting it mildly. A biggie. This is interesting. This is one of the latest things that we're suffering more and more from, as I imagine and know that a load of the other water authorities are. Ductile invert, so invert corrosion in ductile iron pipes. So typically these are pipes from around the sort of 90s, somewhere around that sort of period, and they had a bitumen lining on the inside of the ductile iron. Great product, love ductile iron. Wrong lining, unfortunately. And what's happening is that it's effectively we're getting this invert corrosion occurring on these pipes, where the ductile iron actually wears out slightly in the invert. You're getting some sort of electrochemical corrosion occurring, and we tend to get this lovely little strip developing along the bottom of the sewers, maybe, I don't know, 50 mil, 75 mil wide, pitting at 75 mil intervals. One of the few times we like wet wipes in this industry. You can see that pipe there, the section of pipe that's been taken out. It's held together with wet wipes. What's happened there is that they've basically been forced out where the water's actually going out. They've been forced into the gaps, and they actually seal the pipes up very generously for us until such time as you take the pressure off that rising main and actually let the groundwater pressure. It's in an area, typically with high groundwater levels. The groundwater level comes out and it pushes the wet wipes back in, and next time you switch that main on, you've got a problem somewhere else. It's an ongoing problem. We are doing a lot of work with this at the moment. I've got 3 sites running myself at this present stage where we've got this problem, and we are starting to get pressure liners into these jobs now. They are proving fairly successful in the long term. Obviously, people have got concerns about CRPP linings for this type of stuff, but certainly those pressure liners at the moment, we're getting a reasonable degree of success. But time will tell if this is going to be the solution that we need for these kind of things. Some of the defects you see are actually spectacular on these. The corrosion can be so bad that the entire strip along the bottom will fail and the pipe will literally fold over itself. And we've seen that on quite a number of occasions. It's certainly very, very interesting to see, and quite difficult to deal with. Okay, what are we up to? So what are our drivers for AMP7 basically? So certainly the big thing is dealing with critical assets. I come from a world of doing railway sewers, obviously sewers under railways and stuff for the there, but it's much wider than that. We've got numerous critical assets. It could be a pipe, just because where it is. It could be a pipe that has got such a strategic importance to this, you can't divert it or whatever else. And there's a lot of work going on around these critical assets at the moment, actually understanding them and producing data, producing schedules and mapping whatever else, so that we understand these assets in a lot more detail. That's ultimately, we've got a lot of work going on with the reduction in uncontrolled escape. So a lot of the smaller sewers, we've got numerous sites going on. It's not my side of the business, I must admit, but there is a lot of work to try and stop this going on. We have a lot of problems in central London, obviously, as well, with flooding from sewers. We've got some pretty spectacular stuff. And we have this lovely luxury before long of the super sewer, the tideway sewer coming online, which is going to change things a little bit. It's going to be very interesting, certainly for us, with a lot of the Bazalgette sewers. They're incredibly effective things, and when the flows start getting diverted into them, into the tideway sewer, it's going to be a big change for Thames. Very, very interesting to see some of that going on at the moment. My big thing though is innovation, and unless innovation carries on, we're not going to drive the efficiency to actually inspect and intervene on these things at the right time. Really is going to be a key push for us for AMP7 is to try and bring some of this new innovation in. A lot of it's not going to be accepted, unfortunately. It's the way it works, but we are starting to get things pushed through. Certainly with the CIPP liners in rising mains, they come in generally because of emergency situations where we can't do much else, but then you tend to find those things start to roll out to the wider audience. So we've got a lot of inspection targets. The first sort of sections of rising mains that we're dealing with at the moment. So we've also got a lot of stuff where we're dealing with H2S attack at the moment as well. That kind of brings me on to the opportunities, and those opportunities are quite key. I've touched on some of the issues that we are planning and struggling with. Well, not struggling so much, we know what we need to do, and we've just got to get those plans into place to deal with them. And the key opportunities that we're putting out at the moment are associated with rising main inspections. So a lot of work to be done to actually determine the condition of rising mains. It's not easy. We have to generally dig down, do some sort of testing or whatever else, or in the worst cases, actually taking samples out, taking sections out of these rising mains. That has an associated cost with it. We've got to find better ways of doing this. It's not easy to do, and particularly in some of the assets that we've got, in my world, with the ones that run under railways, actually to get to the rising mains and actually even to take a look at them can be incredibly difficult. Rising main remediation, the ductile iron, I've talked around that already. A lot of work to be done around that, and new techniques being brought on board. Not afraid to look at anything. It's got to be right though, and if we do find ways and means of doing to that, then that can be a game changer, to be honest. And one of the particular issues is dealing with bends that we're are struggling with at the moment. A lot of rising mains with a lot of 90-degree bends on them for some reason, which are very, very difficult to deal with, and actually do make it difficult with the lining type of stuff. Complicated access. We have in London some of the worst, most complicated access you can imagine, and developing techniques where we can actually get onto these sewers, get into these sewers, and hopefully not get into these sewers. You know, that's the biggie robotics, some of the ROVs, and that we're working heavily on a number of projects with this sort of stuff at the moment. And you know, that's the key. If we can get this more automated, it's actually going to enable us to do a lot more work. And certainly trials and programs are going on at the moment to deal with that. High flows, it's a problem. In London we have and certainly within Thames Water, we have a double isolation standard. If we are working in sewers, as far as possible, you've got to double isolate before you're putting people into these sewers. It's not always possible. We've got a lot of Victorian infrastructure with pen stocks, etc. You know, a lot of work being done at the moment to inspect those pen stocks and actually judge them suitable for the work. It's not just a case now of shutting a pen stock and going in behind it. We've got to actually prove that it is safe for the people working down there in a lot more detail. Some of the biggest issues are legacy, though. Certainly the quality of construction that appeared, and you know, I don't know, when we say the 80s, the 70s, the 60s, it doesn't matter. We've got issues in all those sort of decades, and the 90s as well now with the ductile iron pipes. You know, that is probably some of the stuff that's starting to bite us more and more at the moment. And actually going forward, you know, it's establishing and maintaining the quality. I mean, certainly things have picked up in the last few years with CDM and that coming into place as well. So really to deal with that. H2S attack, a lot of products being used, lots of techniques. We need a lot more. You know, the situations are very, very different. We do have some quite incredible H2S attack areas where we're working on at the moment. If you can tackle it early, they're normally fairly easy to deal with. Come in too late, and with some of these things, it's nigh on impossible to deal with. And lastly, sort of the third party damage is something you can't do a massive amount about. You know, we do provide the records, we do tell people where things are, same as anybody else would, but it does come in there and we do suffer these issues. So the piles are difficult to deal with. Generally, you've got to do something sort of fairly heavy to deal with that one. Cutting concrete out, though, you know, the techniques have changed with some of the new robots coming in now. It's making life a lot easier to deal with these sort of things. So, you know, opening it out to the market there, you know, new techniques and that are required, and you know, we will be looking at them as we go forward. So that's pretty much me for the moment. Hand back to you for a second, Ian, if there's any questions.
Hello there, Mark. That was very interesting. Funnily enough, the first question I've got for you here is from Mike Barber, and you've partly answered it, which is because during the past 2 days, we've heard about the effect of H2S attack on concrete pipes and downstream of rising mains. It's a bit of a recurring theme. So any thoughts, is this becoming an increasing problem at the moment?
I don't know if it's becoming an increasing problem. I think it's the time scale it's been going on for now, and certainly with certain types of pipe, yeah, we're noticing it more and more, and it's certainly becoming more of a focus for us as we go through. You know, it's going to be about intervention. If we can actually get in there earlier and deal with these things, it's not all about dosing pumping stations. You know, by the time you need to dose the pumping station, invariably the damage has been done further down the line. But inspect, maintain, and you know, go in with some fairly low levels of remediation. That's going to be the key to it, I think.
So really, you're suggesting that it's the age of the assets now. This is an effect which we're starting to see.
I think from a degree, yeah. I mean, we're certainly seeing, you know, there's a common age, shall we say, on a lot of the assets that are showing the signs of degradation that we're getting from there. Okay. And unless we do something, it's going to get worse, isn't it?
That leads on to a second question here from David Pitt, which is about sewer flushing as an alternative to dosing to change flows and velocities and remove sedimentation and alleviate H2S. Is this something that could be utilized in more situations?
We've certainly looked at it before on a number of occasions now. You know, we have in Thames, obviously dealing with silt is a big thing, particularly on the sort of sewers that run down near the Thames. A lot of it's being done now with the work that's going on Tideway. A massive amount of cleaning is happening, thankfully. But yeah, flushing used to be a way of dealing with things, and would be encouraged, sort of thing. But certainly, I don't think there are any programs. It's not my side of the thing, I'm afraid. I'm more on the dealing with the nasties sort of thing, but not from the operational point of view. So can't fully answer that one, but yeah, I can see the benefit.
Okay. Moving on as well, something you've touched. So this is from David Pitts. Would you agree there's a requirement for more accurate surveys to inform developers of the precise location of critical sewers to prevent the piling incidents?
Very much so. Yeah, very much so. So with Dave's company and numerous other ones we're working with, obviously, with new techniques coming along all the time. Certainly, we use a lot of laser scanning and stuff like that now for the bigger sewers when we're doing the project work. I'd love to make it something that the developer has to do, sort of thing, to if they're working near certainly some of the bigger sewers and stuff like that. But data is the key, isn't it? If we've got that information, then perfect. Yeah.
Question from Barry Westwood is: are you using LiDAR survey for sewer location?
Certainly, if you term in LiDAR as being laser burst type stuff and that, yes, numerous places. We've certainly over the last probably 6 or 7 years, we've been doing more and more of it, and it does have its massive benefits. Obviously, certainly some of the circumstances I think of, where we've been able to drop scanners in and stuff like that to get bulk information. It's not just a point of view of giving you much better data, but from a safety point of view, we haven't got to put people back in there. Some of the major projects I've worked on, we took key decisions to actually spend a little bit more getting some higher quality data at an early stage, and the amount of money it saved was phenomenal, for repeat visits and stuff like that. So definitely, yes, it's something I'm very keen on.
And I'm going to create a last question for you out of the 3 remaining ones, which I've got here from Simon Compton, Graham Howard, and Lee Edwards. It's basically concerning rising main rehab. So with duct, the question is what types of technologies are being used for the rehabilitation of rising mains? For example, for the ductile iron, using reinforced flexible liners or using CIPP, and also you may not be able to answer this, but who's the person to speak to about rising main? I suspect it might be you.
No, probably wouldn't there, but that one I can't answer, I'm afraid. But predominantly the main work's going on at the moment using CIPP for the liners. This is because the degradation has got that bad on them that we've got to put something more structural in there, and much heavier sort of thing. If we are going to be tackling these at an earlier stage, and this is really what I was driving towards earlier with if we can get the scan, get the sensors or whatever else that tell us that you're starting to get some pitting, you're starting to get some corrosion occurring on this one, then it doesn't need to go to the big old CIPPs or whatever else. Are there spray coatings and stuff like that that could be applied to actually remediate at an earlier stage, and that would be kind of the goal, where something can go in that's a little bit cheaper and easier to apply and gives you another 10, 15, 20 years or whatever else, or more. Hopefully, let's say 50 years, there you go, gives you another 50 years. That would be the challenge, and certainly I know there are techniques there at the moment. Until such time as we've identified a few of the rising mains, then the opportunities won't be quite there, but I'd like to be thinking that people are trying to approach our innovations teams to actually do that. And what I would say is that Thames do have an innovations team. They're a very small team, unfortunately, but if people are wanting to actually get things through, that's the route to take.
Yeah. Well, there's a couple of other questions which came through, but I don't know if I made it clear first of all this morning, but any questions that we aren't able to ask the speakers, the Restrade is going to arrange with the speakers for those questions to be answered and for that to be shared. Now, thank you very much, Mark. It was such a good presentation. I allowed you to just run on into a bit into some and to take as many questions as I could.
Cool. Okay. So lovely.
I'm just going to show my screen now, and hang on, sharing, and get the right screen up. Okay. Right. Well, I'm having the unusual situation where I am actually sharing my own or introducing myself and presenting for myself. Now, as I explained, we were going to be seeing or hearing from United Utilities for the current question, but James was unable to attend. Right, I think we've got the correct screen up now. So instead, I am going to present a summary of what we learned in day one and introducing myself in some concepts that we put together when creating this two-day seminar for the first time. Now, I'm a senior research fellow with the Institute for Underground Infrastructure. It is a German-based not-for-profit institute which focuses just on working for sewer network owners to resolve their problems. I also act as their UK and international project manager. As I mentioned before, I chair the sewer rehab contact group, which was a concept that came around really but through the offices of Julian Britton, who we're going to hear from after the break. And Julian wanted to bring together water and sewerage companies to discuss issues of common concern regarding sewer rehab, and particularly the quality control, and ensuring that these will last for their full 50 plus years. We've been meeting for 4 years now and cover a wide range of topics. So in my presentation now, I'm going to cover the 3 areas that we have put together for this project in the first place, for this webinar in the first place. So looking at the approaches to sewer rehab, the consequences of the pandemic, which have been touched upon variously by presenters, and the sort of challenges and innovations which are available out there. So you will be receiving all of the slides, but I thought I would do a quick overview of what we have heard so far. But kicking off really with saying these technologies have been around 50 years now. It was increasingly adopted during the 80s and 90s. But there's a real consequence to this, which is that the water companies have started to realize that their staff with experience have been moving on. There's a recognition, not just really amongst the water and sewage companies, but amongst the industry altogether, that there is a need to bring in new entrant staff and to enhance in-house experience and expertise. There's also this greater emphasis now on realizing that these structures are expected to last for 50 plus years, perhaps 100 years. And also that once rehabbed, you're regarding the sewers as being a new pipe and able to start again. A lot more focus on whole life cost and quality assurance. And finally, at the moment, a lot of realization amongst the water and sewage companies of a need to balance between the proactive and the reactive maintenance. So one of the things that's coming out of that, we're sensing at the moment, is if you like, a renaissance in interest in developing guidance in order to ensure that this stuff will last for 50 years plus. And we're starting to see at the moment an updating of key documents. So Water UK itself publishes water industry specifications and information and guidance notes, and they are looking at those at the moment. Most of us, or some of us, will have received last week a copy of the new Manual of Drain and Sewer Cleaning, which has been produced by WRC and replaces the Sewer Jetting Code of Practice, which was published, about 17 years ago now. SRM, Sewer Rehabilitation Manual, or Sewer Risk Manual, or Sewer Risk Management it is now called, as an online platform. A lot of people have a large red volume on their shelf called the SRM and use it for design guidance, but there's a realization the design guidance was getting out of date. So at the moment, there is a process going on to create a new SRM, which will also be a physical manual that can be used. And I want to finally mention British standards, European standards, and ISO standards on this page. We've got Brexit coming along. Now, this may mean a bit more focus on British standards, but the UK is still part of CEN, which writes European standards. And the other thing to remember is that increasingly, the standards which are used for sewer rehab, particularly for CIPP, are now ISOs, international standards, which sits above Europe. And so the expectation is that we will be continuing with those as the standards for the UK. But standards, I think, are something which everybody needs to take a little bit more interest in going forward, particularly because of the sheer range of new innovations that are coming through in the sewer rehab sector. So we've heard a lot over the last 2 days, and we've still got 2 presenters to hear from about approaches. And what becomes clear is there's a very sort of high sophistication now in prioritizing sewer rehab. And when you get the slides, particularly from Northern Ireland Water yesterday, that Keith Bingham provided us, there's a lot of detail, fascinating detail in there about how this process goes on. And the prioritization, of course, is based upon risk delivery programs, and the whole like the assessing risk of sewer industry has been developing. So when we talk about no-dig solutions, these need to be considered as well, and part of it is the other systems that are going on in terms of allowing us to do this. As I think Mark said, and there's a realization, there's a realization there will always be a need for the reactive work. But by risk management, increasingly, there's more proactive work coming through. And when you look at the programs that the companies are talking about, you'll find that strategic visions which are being set up by the industry and by the companies going out to 2050 are incorporating the need for these aging assets to be upkept. Part of this is efficient delivery, the tackling of known problems, areas, repeating and looking at repeat incidents is one element. Yesterday from Severn Trent, we were hearing about root cause analysis in order to really understand the problem and more efficiently deal with them. Rising main bursts. Now, rising mains have been if you like, the poor relation of gravity sewers in terms of rehab. The gravity sewers have been much more easy to rehab, and so the solutions for rising mains have tended to be more dig down, but increasingly it's realized that you can be a little bit more efficient if you can perhaps rehab before the bursts appear. We're hearing about dealing with the worst hit customers. So of course, sewer flooding incidents within buildings is a complete no-no as far as both, say, CC Water and also Ofwat are concerned. Yesterday as well, we were hearing that, a bit of a focus on you can be efficient if you do a number of small value schemes, which are going to have a high value output, part of the selection. A move as well from piecemeal to more batch delivery of work. And the mantra, risk assessment, prioritization, intervention, I think underlines of what we're hearing about. And let's not forget the innovations which we come on to. Now, I've picked out a couple of other areas which are of particular interest. The artificial intelligence for coding of CCTV. It's been touched upon. There's a general frustration that we have an issue with sewer rehab, that an awful lot of the time has to be spent in manual coding, and that there could be a better approach if it was possible to use artificial intelligence, so that the crews can spend their time cameraing and not coding. And in theory, it would make it get to that goal of being able to survey more sewers and get a much better handle on current condition and changes in condition over time, which CCTV can help with. So there are a number of technologies being developed. There's a huge range of companies getting involved in this area, and a number of the water and sewage companies are conducting trials or evaluations at the moment. So I think this is something to look at. I would be surprised if in 2 or 3 years' time, or by the time of the next AMP period, use of AI was not a standard in the survey side of sewer rehab. Proactive rehabilitation, it is a bit of a tricky one to get it absolutely right, but what we've heard about over the last couple of days are some of the areas for proactive rehab. So obviously the supercritical assets, and we've had several of the presentations which have had some very, very good examples of the consequence of failure. And I knew that, of course, Mark with Thames Water would have a couple of extremely good examples, and certainly in the sewer rehab contact group, it is always quite remarkable to hear about what Thames Water has to deal with the sheer number of railways and the intense urban development over the top of them. Pipe bridges are coming up now, and there's new rehab available for those, because they are effectively underground infrastructure which is overground, so there's different ways you can deal with them. Infiltration, increased interest in infiltration and proactively trying to prevent it, because if you do that, you reduce surcharging of sewage treatment works and the consequences for risks of fines from the Environment Agency for spills to the environment. Trying to prevent events happening. The management of rising mains we've mentioned, H2S deterioration cropping up all the time in the questions and in several of the presentations. And an underlying element of all of this is the need to ensure that risk prioritization is comprehensive, so getting the best possible information and data, and that's been touched upon again in the last presentation. So let's have a quick look at rising main rehab as well. The focus, as I mentioned, was on gravity sewers, not on rising mains. The technology is developing. There's a lot more interest now by the manufacturers of CIPP and other lining and replacement technologies in having their products or making products available for the rehab of sewers. But it's meant that if you like, the standards are lagging behind. There's tests for static pressure tests, but still standards haven't come up with a final definitive approach to dynamic testing, because you've got to deal with negative and positive pressure fluctuations. There have been a couple of dozen trials already in the UK, and there are more to come. But to date, it's been more open cut, except where you're going under a road or a rail or underwater, where it becomes more appropriate to go for a rehab option. And as Mark mentioned, and everybody's finding, it's very difficult to inspect them and to do condition assessment, and particularly because you've got to halt or divert flows. H2S attack has been picked up, greater focus. Yesterday, Anglian said that they were particularly looking at concrete sewers downstream of rising mains, and that has been, we've heard a reminder about that just now from Mark. We've got H2S, but I've also just put in, let's not forget HS2. There are thousands of sewers crossing under railways, or under the route of it, which are being assessed, and there's obviously going to be quite a large program by the water and sewage companies across which these new tracks cross, where there are opportunities for the no-dig industry. Now, let's just move on to the consequences of the pandemic. Now, there's essentially three stages to that for water and sewage companies and for everybody else in the supply chain, which is first of all, preparing for the pandemic. And I've said that's still ongoing because we still don't know exactly how this is going to pan out. And we are waiting to see how this virus develops. And it could be that we've only seen phase one and there's further phases to come, and there may be need for further change. The second stage is responding, which everybody has been doing. And finally will be the recovery. Now, we're not recovering from the pandemic at the moment. What we are doing is still responding. There's a bit of recovery as things change, but we're not into the real recovery phase. The pandemic is not over. So a whole range of consequences for everybody. So work program delivery delays, we've heard a little bit about that. Perhaps changes in material lead time. I know around the world that water and sewage companies have experienced issues with the supply chain and having to create much more robust supply chain. Perhaps an increase in customer complaints and incidents, and a reduction in the ability to attend on site. So when there is a problem, it hasn't been possible for everybody who needs to go and stand around on site and look at it. So new methods have had to be found to deal with that. But what we're seeing during the pandemic was continuation of essential works. What's been important to everybody as well has been essential worker classification for water and sewage company staff, but also for contractors, to ensure that the authorities and the public accept them being on site. Reprioritization of work with no customer interaction, changes to health and safety, and obviously a big one has been the introduction of working from home, which is, of course, where probably most of you today in the audience are working from. What we are seeing is more of the proactive work being able to restart as people have become a bit more comfortable and the national restrictions have been relaxed. But the one thing not to forget about the impact of this pandemic are budgetary challenges. So let's be aware that Ofwat is looking at how this is affecting the water and sewage companies, and Ofwat will be considering whether it needs to make changes to what it's expecting of them. What I can say is that around the world, this is becoming a very serious issue for water and sewage companies. If they are to continue to maintain their levels of service, they're going to have to do the same, probably for less in the future. Now, UK water and sewage companies have a more, if you like, controlled and steady income, but many water and sewage companies which are reliant on public funding around the world are seeing potentially substantial reductions in the money that's available to them. And it's not unreasonable to think that we could see this knocking on into the programs of during the AMP7 period, when we start to see what the real effect is on the water and sewage companies. Quick mention of home working. Most staff seem to like it. Companies have been surprised that actually innovation, productivity and innovation have been maintained and even improved. And actually staff can be trusted not to take advantage when they work from home. And they're starting to see a reduction in office costs, but there are some costs to set up your staff at home. And as we know, there's a substantial body of the workforce that wishes to continue to work from home. So that will result in some change. Perhaps the biggest impact for all of us has been the use of online meeting software. So the water industry has been fairly conservative, but it really has been starting to invest and take on online communication. And you can have, as is there, better, more frequent, faster communication. And We're looking at as well some unexpected consequences, a reduction in expenses some of the water and sewerage companies have seen. So staff haven't been traveling to attend internal meetings or external meetings, and they've been able to use online methods for training. But we always have the local Wi-Fi issues popping in and out, and that's a constant worry for us, for me and the NoDig team from Westrade, about whether somebody is going to drop out in the middle of a presentation. I think as well we have to consider a changing relationship between contractors and clients. So what we've had to see over the last 6 months or so is more flexibility on both sides. Implementation deadlines that can't be met. So that has a consequence of financial penalties, extension of delivery time. Around the world, many of the trade associations have been particularly involved in representing their members in dealing with financial and legal consequence of delay. And there has been some postponement of tenders and offers. So I see the relationship is going to change. It's probably going to be more positive when you hear from some people saying, well, actually, we're finding it much more easily to talk to the client. The clients are finding it easier to talk to the contractors because they're using online methods, and there is perhaps more of a symbiosis going on there. So finally, the challenges and innovations. So this is the third of the 3 areas that we asked the speakers to consider as including in their presentations. So I've put together a few of the challenges we've heard about or are going to hear about. Bit of a change in customer expectation. More customers of domestic customers are at home, and they are able to see a little bit more of what is going on, and perhaps are reporting more blockages and issues, and as we're aware, potentially creating them because we've had this shift from the commercial industrial areas to the residential areas where the majority of the population has been present. There's demographic changes ongoing, a lot of new house building as well, so a lot of issues for sewer networks on inflows. Climate change has been mentioned a few times, the frequency of extreme events, overloading the sewers, the need for resilience. And coming through from this, carbon neutrality. Let's not forget that the water industry has set itself a challenging target of being carbon neutral by 2030. And I was looking just the other day at Scottish Water's new approach, which, apart from replacing its entire fleet of vehicles with non-petrol, non-diesel, and also switching to green energy, it's also planned to halve the mileage that its staff undertake, and that's going to require more automation of the systems, and also less traveling to site. The aging assets I won't dwell on, but the budgetary pressures we are being made aware of. And also going forwards, we need to, as we mentioned at the beginning, attract new entrants into this profession, which UKSTT and others are taking an interest in. And we need to continue with reacting to the pandemic. And finally, just a couple of slides, or a few slides on innovation. So let's not forget as well that the water industry has introduced a new joint innovation strategy involving all water and sewerage companies. They've actually published a draft, and we're expecting shortly the final version of that. They are focusing quite a lot on the Aqua Big questions, so achieving zero uncontrolled discharges from sewers by 2050. So blockages, collapses, CSOs are in the scope. So I think we can see more collaboration between the water companies going forward. And another thing to look out for is that they're planning to create an online collaboration platform to link all stakeholders together. And of course, behind that is the Ofwat 200 million Innovation Fund. So they've published their final approach, which is available online, and they are in the process of appointing an organization to manage that fund, something to keep an eye on. We've heard a bit about innovation over the last 2 days, quite a lot, in fact. So I've highlighted a few of them here, and we've just heard more from Mark. And I know that when Tom Ogden from Yorkshire Water does the last presentation, he's got a list of the innovations they're interested in, but I've put them on here. So survey techniques, the AI for CCTV coding, no-dig methods. I mean, yesterday Severn Trent was mentioning they're looking at methods for removing siphons and lining without having to dig down on them. The rising main lining, pitch fiber management, hydrogen sulfide attack, and this real-time analysis of telemetry predicting flooding and pollution. So a lot, if you like, for the no-dig industry and UKSTT to get their teeth into. And my final slide, I just want to make clear as well, innovation is not just about pieces of kit and techniques. The joint innovation strategy, which has been put together by the water companies, also highlights the organizational and procedural innovations that are needed alongside technologies. And yesterday, Northern Ireland Water, if you look again at their presentation, highlighted a number of organizational changes that they are making. And including, as you see on the list there, in-house modeling, changing their capital works procedures, their program management, introducing KPIs, cost management, programming, reporting. Now, underpinning the joint innovation strategy is a realization that there's a lot of innovation out there which doesn't necessarily see its way through to implementation. So there's going to be a big focus on implementation. And that brings us through to the break. I had one more slide. Expect to prepare for the new normal. We're not going to go back to the way the world was. We will be seeing a new normal, and we hope that this 2 days of presentations will help the attendees to understand that. If you have questions, you can please pose them and I will answer them after the event. So we are now going to take a refreshment break until 11:30 when we are back on again with Julian Britton from Wessex Water, followed by Tom Ogden from Yorkshire Water to complete the 2-day event. So thank you, and we will see you again in a few minutes. Well, welcome back. Hopefully that short break gave you a chance to catch up with your emails and make a cup of coffee. So we are now going to move on to the next presentation, and I'm very pleased to welcome Julian Britton of Wessex Water. So Julian, over to you. We will just have a couple of moments. Right. Julian, we can see your screen with the slides. That's getting towards it. I think you need to possibly do one more screen to get to the full screen. And Julian, are you unmuted? Okay. Yes, Julian, you do need to unmute yourself, which you can do with the little button on the side of the control screen.
How's that? Can you hear me now?
Yes, we can hear you now. Thank you, Julian.
I do apologise for that.
I think we're seeing your sort of fairly large your screen with the.
Right. Can you see my screen now?
Yes, so we've got we've got your next slide as well on the top right.
How do I
It's
get back to
not
normal?
the full screen. So you go to the drop down, I think, under screen share. Not on there. It's in the control panel. Where you go to
Over here?
Sharing. No, and in the webinar control panel. Sharing, where you then get the drop down to the screen where you can show your main screen.
Show screen.
Anyway.
Well, I'll just proceed on this basis, I think.
I'm just checking that I'm seeing a message here to say that the audience can't see your screen. Julian, if you click on the audience view button on your webinar control, audience view, then you should be able to see what the audience can see.
Right, so they can see see my blue slide and the words at the side, yeah?
And do you want to show everybody yourself on video?
No, I won't do that. So I'll just proceed.
I'll leave you to it.
Okay, so you can see my slides there. Okay, great. Okay, so well, good morning and welcome to this presentation on sewer rehab from Wessex Water. I hope you're all very well. My name is Julian Britton and I'm the Critical Sewers Manager in charge of the delivery of the renovation programme. We've seen some excellent presentations on asset analysis and process over the last couple of days, I think you'd agree. My role is that of the contractor within Wessex Water, instigating the works identified by my internal client. And so I'll be addressing the repair mechanisms. If you have any questions regarding asset management, please send them to me separately and I'll pass them on. Here on this slide, you should be able to see the aspects that we'd like to cover. It's not all about CIPP cured in place today, although we continue to explore their evolving capabilities beyond the declared values presented to us by suppliers and contractors. By focusing on mechanical properties of the resin liner matrix, we've refined our own understanding of how they can be utilised to cater for the effective stresses encountered over a number of location scenarios. Asset analysis is important to understand the longevity of our sewers and tunnels at least cost, and at least disruption to our customers. And of course, CEMEX is so important to us now. Sustainability and environmental protection are of the paramount importance. And we use the North American Society of Trenchless Technology O'Sullivan Carbon Calculator some 10 years ago.
Julian, it Currently, your slides are not visible, so I think Alice was going to take over your slides, and then
Carry
you
on.
can
Yep.
ask her to carry them on. So Alice, would you like to put those up, as we seem to be having an issue there? Right, so we are just waiting to see Alice's screen. And Julian, can you see that okay?
Yes.
Right, so if you'd just like to ask her to move slides forward, I think that's the efficient way of doing this.
Okay, you're on the right slide. So back to O'Sullivan's carbon calculator 10 years ago. We calculated that CIPP generated 95% less CO2 than open cut, and the pipe bursting side was 86% less than open cut. We also calculate and report to the Wessex Water Board the amount of excavation avoidance volumes, the amount of excavation and hence muck away that we avoid by using no-dig techniques, which equates every year for us to around about 125,000 tonnes. But that also means we do not import another 125,000 tonnes of graded backfill from the quarries. So that equates to around about 30,000 lorry movements, which don't occur on our roads each year, with all the benefits deriving from that, as you'd imagine. So our involvement with the UK STT and ISTT started the month the team was established in September 2004 and grew with Russell Fairhurst's instigation of the patrons concept about 8 years ago. We also are grateful to Don Grigg and the current chair of the UK STT and Westrade for this opportunity to talk directly to members and share visions. We would not want to miss the opportunity of thanking all past chairmen as well. Thank you. So slide,
Julian,
next slide.
Right, I believe, yes, slides are up. Okay.
Next slide, Alice. Great. So we're one of the smaller water companies with a surge companies out of the 10, and serve a population of about 2.5 million people with surge services and 1.5 million with water services. I won't be referring to potable water mains very much in this presentation, but I would reiterate that we are interested in any new innovation solutions for renovating water mains, as long as those solutions have or are pending DWI Regulation 31 drinking water approval. Focusing on the 35,000 kilometres, I would carry on with the next slide, Alice. So this slide shows the type of problems with which we have to engage. We're common to all sewage companies. I would say at this time we have worked with many inventive suppliers.
Julian, I might have to stop again because it appears that people are still not able to see the slides.
Would it be useful if we skip my presentation today and I record it for you instead?
No, I think we're going to carry on with your presentation.
Okay.
Wait a second, somebody, right, okay. It appears now that the audience can see your slides, so I'm hoping that this is we can continue on that basis. Right, okay, carry on, Julian.
Okay, all right. So this slide shows the typical problems with which we engage, which are common to all of the water companies. I would say at this time we worked with many inventors, suppliers and contractors with new innovative solutions, as you'll see, but there are times when we as the client have a need and cannot find solutions to it. And this means we have a considerable portfolio of our own innovative research programs going on in the background. So most of the expenditure is based around the lining of sewers by CIPP for structural innovation, infiltration and exfiltration pollution prevention. Next slide, please, Alice. Our workload in AMP7, we have an increasing investment in AMP7 and need to address serious sewer defects presented by our planned and reactive needs. We have a framework partnership for our CIPP linings and complete around 30 kilometres per year over structural infiltration and pollution interventions. Beyond that, we are searching for solutions to a number of problems highlighted here in the presentation. Next slide, Alice. So CCTV is common to all of us. And with our 30 to 35,000 kilometers of sewers, we have around about 10 vans on the road every day. And this poor operator has to log every defect, which means we usually only achieve around about 500 meters a day. So what if we could triple that meterage or more and reduce the occupancy on the highways? Next slide, Alice. So in around about 2015, we worked in support of Exeter University's development of their sewer classification factor analysis algorithm. This is big data and artificial intelligence. And they were very successful, had a first run achieved around about 80%, using some very complicated apply filters and classifiers, etc. Exeter University attracted another partner at that time, so Wessex decided that we would explore alternatives worldwide, some of which we saw from the IFAT shows at the time, and we put them onto our marketplace. Next slide, Alice. So our marketplace is on the Wessex Water website, and I would encourage you to check it out because it's in this location that we put our aspirations that we can't find answers to. And this was the place with the defect recognition algorithms. We attracted 31 companies, of which 4 of them are outstanding, and we've taken those on to the next stage of evaluation, and we'll be able to report back on that in 2021, and we look to share that information with all the other water companies as well. Next slide, Alice, please. The next slide is all about filters. Once we have the algorithm in place, we only have a certain amount of TOTEX, as you've heard from the other water companies. We want to spend it on our most deserving assets. So if we came up, for example, with 2,000 lengths of sewer, which were all SRM grade 5 in a particular year, we would then subject that to these filters, such as highway loadings. Some of the roads in Bristol have recently changed, more traffic on them, more axle loadings, etc. The water table can go up and down. The host geology is very important. Are we in a running sand, etc.? And from that, we could refine those 2,000 down to maybe 500, be the ones which would be most critical to us. Next slide, please, Alice. I would just touch on the problem of permitting. It's I know that it's new to us. I know a lot of water companies out there are already involved with it. And this has led us to consider autonomous CCTV in AMP7, and we'll be exploring these to align with our imminent adoption of the CCTV algorithm to further reduce our highway occupancy. Next slide. So in 2015, a number of the water companies came together at Water UK to collaborate in compiling a directory of techniques for the survey of large diameter conduits or tunnels. This comprehensive document took a year to compile, and it concluded with a few survey platforms are available in Europe. This one shown here is the Profiler. The vehicle is still in use by us, and the lengths of sewer achieved are considerable. Our experience at Wessex is we've had one pull of 2,700 meters between shafts, which I think you'll agree is very cost effective. The vehicle laser scans a tunnel or large sewers and overlays these with a photographic still rendering. But also at that time, we were looking at LiDAR surveys, which were being undertaken by the Environment Agency within our region. Next slide, please, Alice. So we brought the Profiler contractor together with our dense point cloud experts and challenged them with the concept of accurate modeling of sewers and tunnels in a semi-turbulent flow, correcting, and you have to go back a slide, correcting and discounting the turbulence with mathematics without the use for a gimbal. All of this is without the need for operatives to enter the barrel of the tunnel and transit long distances, etc. And the furthest we've managed to use this vehicle at the moment is 1,400 meters. The importance here, obviously, is safety. We don't have to put people in, as you can see. In total, we've done around about 8 kilometers, and you may have seen a webinar recently by this company who've mapped out the whole of the Bournemouth CIS for us. And we'll be using this for iterative surveys in the future to see if there's been any diminution at all in the structure. You can see the color coding on that photograph is different levels of deposits or corrosion, etc. Next slide, please, Alice. So this next slide is close to Ian's heart because we've had a long established relationship over the last 15 years with IKT of Gelsenkirchen. When we've identified structural and other concerns in relation to the tunnels we've been surveying with the boats, we can often go in and undertake this MAC extensometer. We came together in 2016 with IKT to deploy this extensometer, as you can see in the photograph, invented by Dr. Olivier Thibault of Eau de Paris, who you may know. He's played a great part in the ASTI3R designs for ovoid GRP liners. And if I can just explain the extensometer, there's a central ram, which you can see there, which is forced out under tons of pressure to only bend the lining of the tunnel by parts of a millimeter, etc. And you can see there are 3 silver bars, which are the spring-loaded extensometers. The one in the middle above the ram will obviously move the most, which is what you would expect. And the 2 at the back and front there will pick up the residual bend in the liner. So that gives us an understanding of how the lining deviates under load. Now, we also do cores, geological cores on the outside to find the geology and lithology. And we also take cores of the actual concrete lining itself, which we crush to get the UCS strength. And when we put all of these together, we can work out via finite element analysis the longevity of the tunnel. And surprisingly, in this particular tunnel, we had some Flexilock plates which had moved, and they looked like they were going to collapse. And the rest of the tunnel looked fine. But when we used the extensometer, we found actually that there were also major weaknesses in the parts of the tunnel that looked capable. That led us to go out immediately and procure 200 meters of GRP tunnel lining to secure the asset, which was 20 meters deep. We'd be very interested in any innovation which allows us such structural analysis through non-destructive means and in non-man entry diameters, such as maybe down the pipe radar, mapping external geology, outside the confines of the tunnel construction, things along those lines. Next slide, please, Alice. I caught the end of Ian's discussion about hydrogen sulfide. It's a major problem for all of us water companies, especially companies in the Far East, etc., and in the Middle East. And you can see a severe hydrogen sulfide attack here. Now, the interesting thing is that the United States Environmental Protection Agency state quite clearly that if you've got more than 5 parts per million of H2S, as you can see here on the y-axis, then you're going to start to have corrosion. And you can see in this particular sewer that we've got in Wessex, that it's way up above that, or average probably around 15 to 20 parts per million. Next slide. So to look for new solutions, we have a long relationship with Sydney Water, and they had 20 years of back data on the use of calcium-aluminum cement veneers. And so we've started to use these. We will take a damaged shaft and scaffold back the sulfate-resisting concrete, which is already there, damaged. We'll clean it up, and then we'll coat it with a 40 mil veneer of dry mix shotcrete. Now, the interesting thing about calcium aluminum cement is that it will resist all attack down to pH of 3. So that's the equivalent of a lemon juice, you know. Beyond that, and up to that point, it sets up a gel layer or a defective protective layer. Beyond that point, it recognizes it's going to be corroded down to a pH of 1, but it still only corrodes at 1/10 that of SRPC. So if your SRPC was going to last 10 years, it would carry on for 100 years. And we're starting to look at this not only in our tunnels, but on our inlets to our sewage treatment works. This is just another example of how we're adopting all these new solutions. Next slide, please. So not wanting to stay still, we started to think about what were the next materials. Next slide, Alice. Right. So we wanted to look at the next generation of materials. One of them is geopolymers, which are like volcanic glass materials, and they're used around the world at the moment, and some epoxies, etc. So we set up a corrosion cell in Bournemouth, which mirrored a corrosion cell used by Sydney Water and Sydney University. And we've had it running now for about 18 months at high levels of hydrogen sulfide. And we're going to be able to report back on which materials fared the best. And that project will come about in 2021. So that's all about biogenic corrosion in hydrogen sulfide rich environments. Next slide, please. In regard to the CIPP, as far as Wessex are concerned, our missing product, our missing link has always been tube-on-tube repairs, junction repairs. And so we have liaised with an Australian company, and literally the materials have all arrived today at Heathrow for this new development, which is called the LatSeal. As you can see in the drawing, the photograph there, the LatSeal hook is spring-loaded, and the hook guides the lateral part of the packer up into the lateral, at which point you then inflate it. Now, if you look at the drawing in the bottom left, you'll see actually that all of the tubes are tapered down towards the connection of the T. So they're all the normal size at the ends, but of the pipe that you want to line, but then they taper down. And this is because when we expand it, we can get away without any wrinkling. The whole of the device actually stretches. And one of the things I'd say is a benefit of the UKSTT is the Young Engineers Award, which is given every year. And a couple of years ago, one of our young engineers, Helen Isaacs, won it, and we sent her to Australia for a month, and she toured all the water companies, soaking up all the best ideas and bringing them home. Another one of the inventions, which I'm afraid we don't have a photograph for today, but it's in the crate, arrived at Heathrow, and that is what is called the CIPR tube patch. So rather than formulating our patches by wetting them out on the ground on a piece of plastic and then wrapping them around the packer and using tie wires, we now have a glass tube, a seamless glass tube, which has a 50% diameter capability of expansion. And we saturated that in a super silicate resin with some polyurea, sorry, which has an E modulus of about 3000 MPa. And that means that it's going to be quicker for us, and installation times on the Super Seal is also going to be shorter. Overall, the LatSeal, for your information, has been used over 250,000 times by Sydney Water alone, so they're very interested. Next slide, please. Ian spoke about rising mains earlier. Again, this is another one of our holy grails. Here you can see an excavation very deep on one of our 800 mils that burst a couple of years ago, and this cost around about £250,000 to repair. So with regard to Gravity CIPP, we now have the manufacturing installation standard ISO 11296, part 7 for riser mains, and we have and well, that is about all we have in relation, because we don't have a recognized design standard in the world for CIPP riser main liners. So we at Wessex Water procured our own, which has a series of 6 concepts. And that came about because of the next slide, please, whereby we were lining the rising main at Christchurch. And when we called for the mechanical properties of the tendering company's linings, none of them seemed to align. They had different values. So by setting up the 6 equations for our own design of linings, we can then help the suppliers to understand what properties they must provide us to go in the equation. So we've turned the whole thing around. And I think this is only going to get better as we work with IKT and the other water companies on the rising main lining project at Gelsenkirchen, which I think we'll be reporting next year. And I think we'll have a much greater holistic understanding. Next slide, please. So coming to the end, our aspirations are to look at new materials. Spiral winding is of interest to us. Bill Menzel introduced it at NODIG in 1987. I know because I'm old enough to remember him speaking. It's been very popular in Australasia, parts of the United States. and certainly is an alternative to GRP lining. And we'd like to explore that. And also, I said I wasn't going to talk about water mains, but they are important to us. And we know of a couple that are reaching accreditation with DWI Regulation 31. It is a challenging situation with out of service, very tight timescales, but we hope to be looking at all of that as well. So, next slide. So, in conclusion, looking worldwide as we do, it seems to us that innovation's become exponential in the last 2 years. There's so much of it. And we're able to bring about solutions which reduce the socio-economic impact and migrate the disruptive elements of our activities, on our customers and give them a better experience of our necessary interventions. So we welcome new initiatives, innovation, and we have a track record of encouraging new concepts. And if you feel you have something new and exciting, then give us a call. Thank you very much.
Hey, Julian, thank you very much for that presentation. Now, because we had a bit of a hiccup there at the beginning, we can use a little bit more time for answering any questions that we have for you, and particularly as well because I don't have to look to do at the end a lengthy summing up, as I've already done it. So what I've got a few questions here for you. The first one's from Mike Barber and says, Julian, do you have an assessment of the percentage of sewers you rehabilitate compared with the lengths of sewer you survey as a sort of rolling annual average?
It's not really data that I hold. That is something that our asset and strategy team deal with. It's hard to say. We survey hundreds and hundreds of kilometers, and at the end of the day, we tend to do around about 30. So you're probably looking at about 5% of what we look at. In reality, like most water companies with 35,000 kilometers, we're the smallest. I think we've only ever seen around about 20% of our network. And that is so low because of course, the adoption of private drainage, and that represented 17,000 kilometers of extra meterage for us. So you can understand it takes time to get around to it.
Okay, the next one is from David Pitt. The use of extensiometers has been successfully replaced by using remote in-pipe LiDAR, providing complete ovality accuracy for the entire circumference. The ability to use this as a repeatable change control method is far more effective than the manual methods shown. Would Wessex Water not consider using this innovative technology moving forward?
Well, we like I said throughout the presentation, we are willing to look at all innovation and as much of it as possible. I wasn't aware of that. I'd be interested to see how it compares with the ability that we've got to bend the lining at the moment. But like I say, David, yep, contact us and we'll have a look at it.
Okay, and the next one is water industry should help themselves by providing enhanced access to rising mains to facilitate future inspection, mapping and remediation. When repair is done, future access should be installed. That's a question.
Well, we would agree. We tend to only install access points when we want to survey them, but from the beginning it makes sense, as do so many other things in life, really. Things like having twin rising mains under major rivers and things, so all of these things should be addressed. I suppose at the end of the day it comes down to cost as well, but yeah, absolutely agree.
Yes. Thanks. Well, actually, that's here's another one. Are you looking to introduce spiral wound lining in your tunnels and sewers?
Well, as I said, it's one of the things we want to look at. We've started to do so. I'm only aware of a handful in Great Britain since Bill Menzel in '87. I think about 4 of them under the Millennium Dome. There's a couple up in the Midlands. The Environment Agency up there did one recently with Sekisui. If it does offer cost savings and we get the same structural integrity, then obviously it would be a winner for us and we want to look at it. We've got many friends, certainly in Australia and South Africa, who've been using the system. So I'd have thought it's about time somebody here gave it a go, and maybe it'll be us.
Okay. Thank you. Well, that actually does conclude the questions that I can see on the screen here. So again, apologies for the glitch at the beginning. The slides that Julian was showing will be made available. So you can go through those again, and I guess contact Julian if you have particular questions on that. So Julian, thank you very much for your presentation.
Thank you.
And we will now move on to Yorkshire Water and Tom Ogden. So Tom, over to you. You need to unmute yourself, Tom.
Sorry, it's schoolboy error there. Good morning, everybody.
And to
I
share
shall
your
show my screen, and hopefully that's the right screen, and that will work.
You can check using the audience view button on your control panel.
Yeah. Yeah, audience view. So audience can see that. 2 seconds. I shall put myself into slideshow mode.
That's good.
And the audience can see my slides. Yeah. So yeah. Thank you very much. We've got there now. So yeah, I'm Tom Ogden. I am an innovation technical specialist at Yorkshire Water. So my presentation today is going to be a little bit more innovation focused, a bit of a whistle-stop tour of what's going on in Yorkshire, the challenges that we face, and sort of what we're currently doing, what's in the innovation programme, and a bit of what we'd like to see as well. So I shall crack on. So move on. Yeah. So yeah. So these are the challenges. Current rehab programme, innovation programme. What we'd like to see. So as we all know, Yorkshire is God's own county, but we do have a few problems, and we've got some very challenging targets throughout AMP7. So internal flooding being the major one there. So we've got a target of a 73% reduction in internal sewer flooding, 36 on pollution, 21 on external escapes, which is a sort of a new sort of measure really that's been brought in this time, and a 15% reduction in collapses throughout this AMP period. And I think if I tell you a little bit about the sort of the sewer network, and the issues that we have, I think that helps to explain things a little bit why those targets are so challenging. So we've got about 5 million customers in Yorkshire Water, 1,000 kilometres of river, 12 long sea outfalls, 640 treatment sites, 58 sludge treatment sites, get through about 1 billion litres of sewage treated per day. And we've got 58,000 kilometres of sewer. So 22,000 of those were transferred in 2011, but we've only got about 33,000 kilometres of our network mapped. So we've got a large chunk of network that we don't have visibility of, which causes lots of issues. We've got 2,700 pumping stations, of which 720 were transferred in 2016, approximately 1,300 kilometres of rising main, 1,900 combined sewer overflows, and more than 2 million manholes. And it's a jolly big place with lots of sort of different areas and different problems, from your big cities to your rural catchments. So just a few of the issues here that we've got linked to internal sewer flooding. So yeah, it's not all green pastures in Yorkshire. Lots of old housing stock, terrace properties. So approximately 260,000 cellar properties in Yorkshire. which come with some unique problems. So really limited access to survey and rehabilitate the network due to the lack of manholes. Significant amount of small diameter network running close to these properties, and a lot of this remains unmapped. It is one of the oldest sewer systems in Western Europe, and the majority of internal flooding is into cellars, and we have a lot of cellar properties. So it's all the vitrified clay, sort of 4-6 inch sewers. All it takes is a little blockage, and it can cause it to leak into the cellar below, which causes lots of issues. And just a little bit about the pollutions. So this is the second most challenging target. So most pollution incidents reported to Yorkshire Water come from the sewer network, often hard to reach places for inspection and maintenance. Manholes within those hard to reach places, often really hard to locate, which makes it even more difficult to do any maintenance or surveying of those assets. Conventional CCTV it's challenging to get to some of the places we need it to be, and telemetry is a big issue on the network as a whole, but especially around pollution areas. So we've got over 2 million manholes and less than 3,000 level monitoring points on his network. That is improving, but still a long way to go. So this is just a few nice pictures of what we're trying to prevent at Yorkshire Water. So what we're currently doing, so this is based around our proactive programme, doesn't sort of take into account the large amount of surveys that are carried out every day on a reactive basis and repairs. But yeah, we've got lots of different schemes ongoing that I'll just give you a quick whistle through to sort of explain, so a bit of an understanding of where our focus is for this AMP period. And I think that target of 73% reduction in internal sewer flooding, I think that's a key thing that we're focusing on, as you'll see through the schemes. So we've got various different find and fix programs going on. So the biggest one of those is the proactive sewer investigation team looking at internal sewer flooding. So we're looking to survey 150,000 properties. So that's visual inspections, CCTV, and trying to get it. That poses challenges with trying to get into the properties and trying to get access to our assets. But we've got a target of 1,600 defects to repair on that programme. 37 different teams being utilised, and the properties selected for this are on a geographical risk basis. So the whole areas are being selected and surveyed, and that's mainly done on based on history of flooding and cellar properties mainly that we're looking at there. This AMP we have taken the same approach with external sewer flooding. So same approach, very different areas, more around maybe a 1960s developments, 1950s, 1960s developments, where we've maybe got repeat blockage problems. We don't get internal flooding there, but we do get lots more in external flooding. We're targeting 28,000 property surveys. Again, going to the property, looking at the assets and cameraing all around. And yeah, 3,250 defects we want to repair off the back of that. And we've got 8 teams conducting these surveys. And the other one on here, the Find and Fix programme, is working a slightly different way. It's looking at risk properties, specific at-risk properties rather than areas. and looking for the highest risk properties and going one property either way with the surveys. So it's probably within a similar area, but much more focused on the real high risk properties. We're looking to do 13,000 properties with that program, inspections and repair approximately 1,800 defects. We do expect to find significantly more defects than 1,800 than we can repair in all these programs, but these will be prioritized by our asset planning team. So some of the other programs that we've got, our proactive CCTV program, we've got a target of 350 kilometres of main sewers to camera. All surveys have been coded and integrated into Info Asset Manager, and we are looking to make approximately 800 repairs off the back of that. Rising main rehab wise, we've got 12 sites currently being investigated for rehab work, 2 sites being promoted for relining work. So we have got a Sanitube liner installation coming up, and we are looking to do a spray in situ liner that is looking to be used as well. We've got desilting work going on, doing 78,000 metres of desilting linked to pollution risk and 140,000 metres linked to high risk internal flooding areas. We've got a sweep jetting inspection programme, going and visiting the high risk pollution sites. That's based on 225 and below, and often we find that jetting's maybe not possible due to the location, so it's more of an inspection type program. And then we have some sort of larger schemes that are being delivered through our AMP7 framework. At the start of this AMP, we set a new framework out, and there's various different blocks of work within there. One of those is our network rehab, which we've got 13 schemes in total going into that. We've got 9 clusters of properties where we'll go in and rehab all the assets in that area, plus 4 other slightly different streams of work. And we've got multiple different organisations carrying out that surveying and repair work for us. And we do have lots of large schemes currently in the investigation stage with our strategic planning partner Stantec. These are largely linked to capacity issues, so waiting on pipe hydraulic surveys and such like. So what have we got in our innovation programme? We've lots of exciting things that we're looking at the moment. We've got actively in our programme. So yeah, I'll whistle through them for you. As mentioned previously, we've got a lot of access issues on our network, so really difficult to get from get into the customer's premises to do a survey, and B, come back and B, camera that network, get access in. There's a severe lack of manholes, and so we're looking at different ways to do this work. So we've purchased 2 IPEC lateral CCTV vans, and we're looking to increase our understanding of the location and condition of our lateral sewers with this programme, to help prioritise our rehabilitation programme. So yeah, we're trying with the idea of working from the manhole in the main road back up to the customer's property without the need to sort of access at all and that property. And we're also looking sort of for the better data capture here. So other programs we do using push rods, we're not coding the data. With this program, all the laterals will be coded, and we're using software which will allow us to map all those laterals as well. So we'll get a really good picture of our network. And in the same vein, on the right hand side, we have got our spray lining of laterals program. So aim is to reduce the number of internal floodings by enabling the rapid rehabilitation of our sewer network. So we are working with a couple of companies to develop the technology to enable the spray lining and the material to spray line onto the pipes. And again, this is the idea of this is to work from the main sewer and go back upstream and to every lateral, spray lining it and coming away and being able to do a full street at a time and walk away from that street having rehabilitated all our assets. And it just removes all those access problems that we do have with other programs of work. And we're hoping that by removing the access problems, removing the need for digs, then we can really get into the reduction in cost as well. So that's an exciting one. And this is, I suppose, it's to illustrate the point why we're going after these two technologies. This is a typical sort of tourist street in the Bradford area, and as you can see, that's what we've got on our records. Not a lot mapped, and much more T2011 sewer in there, and yeah, very severe lack of manholes. We've got some other exciting projects that we are on with. So we've got a rising main survey, clean and rehab project just coming forward. So we're looking to evaluate lots of different techniques for that inspection and develop sort of a package of techniques we can use that we can to understand what the best way of repairing that rising main is. Then we're also looking at various different cleaning techniques, ice pigging, gel pigging, and maybe whirlwind as well. But we're trying to sort of really understand and prove these things so that we can give the business confidence. Working with the IKT and the UK partner project on the rising main rehabilitation project. So that's our rehab element, and also looking at smart air valve technology, all with the aim of giving us a better understanding of the condition of its rising mains and how to rehabilitate them. So everyone seems to have the same problems on the calls today. So we're trying to address all those issues. Another really exciting project for us is our low-cost sewer monitors. So we're aiming to develop a device at a price point that will allow us mass deployment, giving us much greater visibility of performance of all parts of its network. So we've got a severe lack of visibility of what's happening in a sewer network at any one time. So we're developing a device that can go in a manhole, but it can also go on a soil stack or in a gully. It's going to be very affordable, and we're looking at sort of 5 different sensors within there. So not just thinking level is the be all and end all. We've got we're looking at other ways of understanding our sewer network. And a couple more that we've got ongoing at the minute. We recently purchased 5 of the QuickView cameras, and we've deployed them out to understand where we can get the best benefit with that technology. Looking at working in sort of highways where we can't normally get to, trying to address some of the issues caused by the all streets permitting. So we're trying to do that quick survey, get in, get out, get the information we need, and confirm the assets working as it should. And a project that we're just about to start is our satellite, aerial, and drone fault detection. So trying to improve information on our assets to give us better overall assessment. So looking at things like using the satellites for ground movement, groundwater, so maybe to indicate future failure or maybe an infiltration problem. Aerial surveys, can we actually map using an aerial survey? So can we put some of the nodes on our maps that we're missing, or even some of the length of sewer or rising mains, and also can we deploy drones within the sewer to speed up our CCTV surveys and reduce the need. So that's some of the things we're going to be looking at in that. And then we've got some of the innovations we'd like to see here. So some of the things we're thinking about, and if anyone out there has got some more details on these, we'd be more than welcome to accept your sort of contacting us. So some of the things that we're interested in on here, I've just gone into a little bit more detail. So we're having increased problems with the number of deep excavations, 2.5 meters deep plus on small diameter sewers. So probably just going into the highway away from the customer's property. We'd love to see a method of repair that prevents the need for your typical 5-meter long excavation with shoring and all the works that closes the road and disrupts the customers. Could we dig down directly onto the collapse using vacuum or some other technology through a 500mm hole and maybe install a insert repair onto that collapse, or maybe working from either end of either manhole, put a liner through and do something there. CCTV auto coding, something we're very interested in, but maybe the next step could be adding sort of GPS capabilities to our camera kit, and above ground and underground mapping technologies to enable us to sort of one-stop shop, go inside, presses a button, it knows where the camera is, it knows where it's been, and that gets uploaded straight back to our systems. I've got a few sort of linked points here, sort of what we're trying to do with our network monitors is give us some real-time visibility of asset performance. I think that will flow nicely into sort of live hydraulic models of our network, sort of allowing us to predict exactly when we need to attend to remove a blockage from the network and before it causes a customer problem. And then that could build into automated hydraulic control of the network, holding back flows in a rainfall event. Can we operate the network differently to improve the treatment process? That's something that we are looking at. And then there's just thinking about hydrophobic non-stick liners. Can we get the flow through our network a bit quicker and more cost-effective survey techniques? If there's ways of surveying a network that's quicker, cheaper, but it still gives us that same data on the how it looks, that we'd love to hear from people on that. And that's full information on our innovation program can be found on our website, where you can also contact us from there. And that's me. So any questions?
Oh, thanks very much. And in fact, you did answer one of the questions which I've got here, which was how do you become a supplier to Yorkshire Water or contact Yorkshire Water? So I guess you've got the contact there to the innovations online.
Yeah, we are a small innovation team, but we will get back to people if they want to contact us.
Okay, then I have a question for you. Out of your 2 million manholes, do you know approximately how many have been rehabilitated?
Not enough, I think would be the answer. No, I wouldn't know that. I think it's a very small amount rehabilitated with any sort of the spray lining techniques or anything like that. We'll do a lot more sort of man entries to repair inverts and things like that on our reactive program.
Okay, then
sorry, I don't have an answer to that precisely.
Okay, I think we've still got you, Tom. There was a slight delay there, I think, with your microphone and your webcam. There was a slight delay with your microphone and webcam, but I think we've got you still okay. Yes. Well, I'll ask you the next question, which is...
I can just hear you, sorry, and it's just dropping out a little bit, probably at my end.
Yeah. Okay, well, this was a question which I think was following on
Yeah.
from Julian's mention of the lat seal from Lee, saying what type of technology are you looking to use for junctions in trenchless repairs? This is where you've got a lateral connecting onto a main sewer. Tom,
so so we are looking with working with Axalta. Oh, sorry, can you hear me, Ian?
Sorry. No, I think there might be a problem with the
Maybe
web connection at your end. The question was, yeah, how to deal with the how you're dealing with the lateral connections and rehabilitating of lateral connections.
Yeah, so I'll try and answer that. Hopefully you can hear me.
Yes.
So yes, so we are looking through our lining of lateral sewers program. We're looking to be able to go from the main back up and spray line that entire line. So looking at working with Axalta to develop a material that will cure quick enough but be structurally sound enough to make that seal. So we're not looking just for the junction, we're looking to get right back up to the property and fix that entire line.
Okay, then I've got a question, which is, Tom, why is Yorkshire Water not using Class A CIPP for the RSM rehab? I think the RSM is rising main rehab.
Good question. I don't know enough about the technicalities of the CIPP liners, but I can ask the questions and get back to people if afterwards.
Yep, I do point out again that we will be asking the speakers to answer all questions. So another question from Steve Peregrine, which is upstream inspection of laterals from the main is common practice in Central Europe, notably Germany and Austria. This can be further enhanced using GeoSense lateral launch camera equipment that uses accelerometers and can continually plot the three-dimensional geometry of the pipe. Are you going this far with your camera equipment that you've invested in?
We'd like to do, yes. We are talking with our suppliers to enable as much of that sort of ability as possible. That's the ideal for me, to be able to give the guys on the van less to do and and get the technology to do the heavy lifting.
Okay, thanks very much. And have you considered use of structural GRP slip liners on larger storm sewers?
Not something that I'm close enough to comment on, I'm afraid.
Okay,
but
so
it's something that we can ask the question. It's definitely something we'll consider all options when looking at solutions. So yeah, it's definitely something we can consider.
Thanks. And I've got one question. I'm just checking here. Yeah, one question myself for you, because you're involved in innovation. You're in the innovation team, and innovation is a bit of a theme for everybody. I would guess perhaps you could whether you can make a few comments on the way you see it going forward with collaboration between water and sewage companies, particularly with this new joint innovation strategy, which is being published by the water companies. Tom, I think you might have frozen up again. Perhaps if you okay, perhaps if you just switch off your webcam.
Yeah, I think we all have the same or very similar problems. Let me. I've just turned my webcam off. And see if that helps.
I think your audio's better now.
Yeah, can you hear me?
Yep. Yes.
Yeah, I think you got most of that question, Ian, about the.
Yes, it was really about the.
Yeah, I think you got most of that question about the sort of the innovation program.
Collaboration under this innovation program.
I can see there's much more need to collaborate. Where I suppose we're open to collaboration with any water company. So if anyone's out there listening and they said I like the sound of that project, I'm always happy to share. There's no point in us all running off and doing exactly the same thing in different areas. And hopefully the innovation strategy will focus a few minds around some of our big challenges, and it'll enable us to be able to work together to overcome them and not work in silos within the water company. Well, about the end of the world.
Thanks very much, Tom. And that's a fairly positive note to end on in terms of looking to the future. So it remains for me to make a few final comments or notices. Now, because of the change that we had to the program, I was able to provide the full sort of summary I would have been done in a longer form. So it remains for me to remind you that the UKSTT and NoDig Live has been delayed to March next year, and the plan is to hold the event on the 23rd, 24th and 25th of March. So do keep an eye on the NoDig Live website and any communications you get about how that develops. Also to be aware that during that period on the 23rd, 24th, there's going to be the first European NoDig conference held simultaneously with NoDig Live. So an event to look forward to. It remains for me to thank all of the speakers, including those who were unable to attend at the last minute, and to thank you, the audience, and for putting up with the odd glitch here and there and the odd loss of the internet, which is just a problem we're all having to deal with at the moment. I would like to thank the team at Westrade, Alice Nolan and Lee Abbott, who have been responsible for pulling this together and for dealing with the communication, all the communications, and a thanks to UKSTT, to Lynn McLaughlin and to Dawn Gregg, the chairman, for their involvement in this. So thank you all for attending. Slides will be available, questions will be answered, and we look forward to seeing you next time. So goodbye.